What lies beneath the swirling clouds of Jupiter? Is it just storms and gas or something far stranger? Deep within this gas giant, scientists have uncovered shocking phenomena that could rewrite everything we know about planets. From colossal lightning storms to mysterious gravitational anomalies. What secrets is Jupiter hiding? Get ready, because what you're about to discover may change your understanding of the universe. Welcome to the Power of Science, the place where curiosity fuels discovery. If you're fascinated by the mysteries of space and the secrets science is just beginning to uncover, you're in the right place. Subscribe and join our growing community of cosmic explorers. Type in the comments, "I am part of this transformation," to show your commitment to learning and discovery. Jupiter, the largest planet in our solar system, has always been cloaked in mystery. From ancient astronomical records to modern space telescopes, one question has remained unanswered. What lies beneath its dense, ever-shifting clouds? For centuries, scientists could only speculate. But now, thanks to NASA's Juno mission, we're finally peeling back the layers of Jupiter's atmosphere, and the discoveries are rewriting everything we thought we knew about gas giants. From Earth, Jupiter appears as a mesmerizing swirl of colors and storms. Its great red spot, a storm so large it could engulf 3 Earths, has raged for centuries. But beyond these surface features lies a world of chaos and beauty. What causes these storms to last so long? What materials make up these clouds? And why does Jupiter emit more heat than it receives from the Sun? These questions have puzzled astronomers for decades. Theories suggested that Jupiter had distinct atmospheric layers leading to a dense, rocky core. But Juno's data is revealing a much stranger story. Launched in 2011 and orbiting Jupiter since 2016, the Juno spacecraft is equipped with advanced instruments like GIRAM, an infrared spectrometer, and MWR, a microwave radiometer. These tools have allowed scientists to peer deep below the planet's cloud tops. What they found shocked the scientific community. Jupiter's storms don't stop at the surface. They stretch thousands of kilometers into the planet's interior. That means Jupiter's weather is not just a surface phenomenon. It's a deep, multi-dimensional engine of raw power. Even more surprising, Jupiter's atmosphere doesn't behave like Earth's. On Earth, atmospheric layers are relatively distinct. On Jupiter, however, gases appear to blend more like a single massive ocean of fluid. These gases move at incredible speeds, with jet streams flowing in opposite directions and storms that twist like living creatures. Imagine an entire planet where the air behaves like molten liquid. Storm systems last for centuries, and no single place is ever truly calm. As Juno dived deeper, it detected unexpected gravitational anomalies, variations in Jupiter's gravitational field that couldn't be explained by conventional models. These clues suggest that Jupiter may not have a compact, solid core, as once believed. Instead, it might have a fuzzy core, where heavier elements are mixed with metallic hydrogen, an exotic state of matter that exists only under unimaginable pressure. So what exactly is metallic hydrogen? It's a phase of hydrogen theorized for decades, now believed to exist deep inside Jupiter. Under pressures millions of times greater than Earth's atmosphere, hydrogen atoms compress so tightly that they release their electrons, creating a metallic, electrically conductive fluid. Scientists believe this material is responsible for Jupiter's immense magnetic field, the strongest of any planet in our solar system. Just how strong? Its radiation could destroy an unshielded spacecraft in seconds. But that's not all. In 2021, new data from Juno revealed something even stranger: lightning in the upper atmosphere. Traditional models said this shouldn't be possible at such altitudes. The presence of lightning high in Jupiter's clouds suggests water and ammonia are being carried farther upward than we thought. This could mean that complex chemical reactions, perhaps even prebiotic processes, might be occurring deep within Jupiter's cloud layers. While no one's claiming life exists there, the chemistry is much more complex and surprising than we imagined. Each new layer we uncover raises more questions than answers. Jupiter isn't just a planet, it's a cosmic mystery, and it's only just beginning to reveal its secrets. The more we learn about it, the more we also learn about the birth of our solar system. After all, Jupiter was the first planet to form, and its gravity helped shape the destiny of every other world, including Earth. And what else has Juno found? Rotating megastructures beneath the clouds, cyclones organized in geometric patterns, magnetic pulses that come and go, a glowing internal heat that defies thermodynamics. Jupiter is more than a giant planet. It's a gateway to understanding the universe itself. And in the next blocks, we'll dive even deeper into these phenomena and the revolutionary science behind them. As we move deeper into Jupiter's mysteries, one discovery stands out above all: the planet's polar cyclones. When Juno first captured infrared images of Jupiter's poles, scientists were stunned. They weren't expecting to see neatly arranged storms, but that's exactly what they found. At Jupiter's North Pole, 8 massive cyclones spin around a central storm, forming an octagonal pattern. At the South Pole, a hexagonal arrangement of 6 storms surrounds another central vortex. These aren't small tempests. Each cyclone is thousands of kilometers wide and powerful enough to swallow an entire continent on Earth. Even more mind-blowing, these storms have remained stable for years, locked in position like gears in an invisible machine. On Earth, storms lose energy and dissipate over time. But on Jupiter, the rules seem different. These polar cyclones aren't held together by land masses or ocean currents like on Earth. They exist entirely in an atmosphere of swirling gas. Scientists believe that temperature gradients, planetary rotation, and deep atmospheric currents all contribute to their surprising stability. This is one of the clearest signs that Jupiter's weather systems are operating on a scale, and under physics, we're only beginning to understand. But that's not the only anomaly. Juno also gave us unprecedented data on Jupiter's magnetosphere, the bubble of magnetic influence that surrounds the planet. It turns out Jupiter's magnetic field isn't just the strongest in the solar system, it's also highly irregular. Instead of being shaped like Earth's fairly symmetrical dipole, Jupiter's magnetic field is lopsided. One area near the equator, called the Great Blue Spot, is unusually intense and chaotic. This suggests that the processes generating the field deep within the planet are asymmetric, possibly linked to how metallic hydrogen flows around its fuzzy core. This magnetosphere extends up to 7 million kilometers toward the Sun and almost reaches Saturn's orbit in the opposite direction. Within this magnetic domain, high-energy particles are trapped and accelerated to extreme speeds, creating powerful radiation belts that are deadly to spacecraft and humans alike. If Earth's radiation belts are like a warning sign, Jupiter's are like a nuclear furnace. In fact, NASA had to engineer Juno with special titanium shielding just to survive orbiting the planet. Another shock came from how deep Jupiter's weather penetrates. Before Juno, scientists assumed the planet's iconic bands and jet streams were relatively shallow features. But microwave data revealed they extend as deep as 3,000 kilometers into the interior. That's about a third of the way down to the center of the planet. Imagine Earth's entire atmosphere stretching all the way to its core. Now multiply that by 10. Jupiter isn't just a gas giant, it's a weather machine with patterns that run deep into its soul. And it gets stranger. Jupiter emits more heat than it receives from the Sun. This has been known for decades, but Juno's data shows this internal heat may not be distributed evenly. Some regions seem to be hotter or more dynamic, suggesting that upwellings of energy from deep within are influencing surface storms and jet streams. Think of it like a giant pot of boiling soup, with hotter currents rising from below and driving atmospheric chaos on the surface. All of this points to one central truth. Jupiter is not just a stormy gas giant. It is a living system of complex, layered dynamics, from the molecular to the planetary scale. The deeper we look, the more we see a planet that defies easy classification. Is it a failed star, a laboratory of exotic physics, or perhaps a relic from the early days of the solar system, carrying secrets about the birth of all planets, including Earth? In the next section, we'll go even deeper. What do these discoveries mean for the search for life? Could the chemistry in Jupiter's clouds tell us something about prebiotic evolution? And what happens when we compare Jupiter's behavior to that of other gas giants, or even exoplanets in distant galaxies? Stay with us because the real cosmic journey is just beginning. The further Juno probes into Jupiter's atmosphere, the more it dismantles what we thought we knew about gas giants. Among its most groundbreaking insights is the suggestion that Jupiter may not have a defined solid core at all, at least not in the traditional sense. Instead, scientists now propose the existence of a fuzzy core, a vast region at the planet's center that's partially dissolved and intermixed with surrounding gases. Rather than being a dense, compact ball of rock or ice, this fuzzy core is diffuse, stretching across nearly half the planet's radius. This upends decades of astrophysical modeling. If Jupiter lacks a sharply defined core, how did it accumulate such a massive gravitational footprint? And more importantly, how does this affect the way planets form across the universe? Let's now turn to the composition of Jupiter's atmosphere, which Juno has helped map in more detail than ever before. The spacecraft's microwave radiometer has peered deep below the upper clouds to reveal unexpected chemical distributions. For example, ammonia, once thought to be limited to the outer layers, is present in varying concentrations throughout the planet's interior, suggesting massive weather systems and chaotic circulation patterns that redistribute materials on a planetary scale. These dynamics hint at a layered but mobile internal structure, something unlike anything we've seen on Earth or even on Saturn. Another surprise? The presence of water deep within Jupiter's atmosphere. While water is abundant across the solar system, confirming its presence in Jupiter at specific altitudes and pressures helps scientists refine models of how the planet formed billions of years ago. It also gives insight into the disk of gas and dust that once surrounded the early sun, providing a kind of cosmic fossil record encoded within Jupiter's layers. Now, let's revisit the Great Red Spot, a gigantic storm larger than Earth that has raged for centuries. Juno has flown directly over this colossal vortex, using its instruments to probe its depths. What it found was stunning. The Great Red Spot extends at least 300 kilometers down into the atmosphere, making it a three-dimensional phenomenon unlike anything on our planet. It's not just a surface-level storm, it's a deep vertical weather engine, likely driven by internal heat and atmospheric dynamics that we still don't fully understand. And even more intriguingly, the storm appears to be shrinking slowly over time. Could we be witnessing the slow death of one of the solar system's most iconic features? Meanwhile, new mysteries continue to arise. Scientists analyzing Juno's data have found unexpected asymmetries in Jupiter's gravity field. These might be caused by deep atmospheric winds interacting with denser materials, or even hidden anomalies within the planet's interior. The complexity of these signals points to something extraordinary. Jupiter isn't just a static ball of gas. It's a dynamic, evolving world with layers of structure, energy transfer, and possibly even unknown phases of matter under extreme pressure. Juno has also detected lightning storms in Jupiter's atmosphere, similar to Earth's but happening in vastly different conditions. These bolts are generated in clouds made not just of water, but also of ammonia and other exotic compounds, where temperatures plunge to -145 degrees Celsius. The fact that lightning can exist in such an environment suggests that electrical processes in planetary atmospheres are far more flexible than we previously imagined. Finally, one of the most intriguing aspects of Jupiter's behavior may lie in its interaction with the solar wind. The planet's magnetic field stretches so far into space that it creates a vast magnetotail, an invisible, comet-like trail of charged particles that extends millions of kilometers away from the Sun. This magnetic shield not only protects Jupiter, but also affects its moons, its rings, and even the behavior of particles around it. Juno's data has shown that the coupling between Jupiter's magnetosphere and its atmosphere creates feedback loops, complex interactions where magnetic energy is transferred into atmospheric heating, auroral displays, and potentially even large-scale climate patterns. What emerges from all these discoveries is a planetary system that defies simplification. Jupiter is not just a giant ball of gas. It's an engine of motion, a magnetic powerhouse, a swirling ocean of metallic hydrogen, and perhaps even a clue to how life-supporting planets like Earth came to be. In the final section, we'll tie these revelations together and ask the ultimate question: What does Jupiter still hide? And what does that say about us? As we bring together the insights uncovered in Jupiter's deep, stormy layers, we begin to understand that this planet is far more than a gas giant. It is a cosmic archive, a mystery in motion, and a gateway to understanding the very nature of planetary evolution. Each layer, each swirling storm, each unexpected anomaly forces us to revise what we thought we knew, not just about Jupiter, but about the origins of our entire solar system. One of the most groundbreaking aspects of Juno's discoveries lies in the realization that planetary formation is not a closed equation. The idea of a rocky core neatly collecting gas from the solar nebula has been challenged. Instead, the chaotic, swirling birth of Jupiter, marked by violent collisions, intense gravity, and constant motion, may point to a model where fuzzy boundaries, diffuse materials, and massive internal mixing are the norm, not the exception. This redefinition carries weight far beyond our own system. If Jupiter's internal structure is this complex, what does that imply about the exoplanets we've found, many of which are even larger and more extreme? Could similar dynamics be hiding in the giants orbiting distant stars? And more importantly, what forces shape planets into habitable worlds? Could Jupiter's behavior, its magnetic shielding, gravitational interactions, and ancient composition have helped create the conditions that allowed Earth to flourish? Think about this. Jupiter's gravity acts like a shield, protecting inner planets from many comet impacts. Without Jupiter, Earth's surface history and the evolution of life might look very different. This enormous gas giant, seemingly distant and unrelatable, may have played a critical role in Earth's survival. But the questions keep piling up. What else lies deep beneath Jupiter's clouds, perhaps inaccessible even to Juno? Could there be unknown elements or physical states of matter beyond our current understanding? How do Jupiter's 95-plus moons, some of which may harbor subsurface oceans, fit into this cosmic puzzle? Jupiter is no longer a static image in our telescopes. It's a living system, breathing with energy, erupting with storms, and teaching us humility in the face of complexity. Every mission, every orbit, every byte of data tells a story of chaos, beauty, and the raw power of the universe. And still, so much remains hidden. Juno's mission has already been extended, but even its upgraded orbits can't answer all our questions. Future missions, perhaps atmospheric probes, robotic landers on its moons, or even sample return technologies, may be needed to crack Jupiter's deepest mysteries. What we've discovered so far is only the beginning. In the next decade, we might witness a revolution in how we understand gas giants, not as leftovers of cosmic construction, but as key architects of planetary systems. And that revolution starts here, with curiosity, with exploration, and with a camera aimed at the clouds of Jupiter. If this journey through Jupiter's mysteries blew your mind like it did ours, don't stop here. Watch the next video. Saturn's rings are disappearing. Here's what that means. Is there life beneath Europa's icy shell? Comment now. Science is the key to the universe. Let us know what theory or discovery amazed you the most. Subscribe to The Power of Science to stay updated on the most mind-bending mysteries of the cosmos. Because the universe is just getting started, and so are we.